You're lying in bed. Your body goes soft, muscle by muscle. Then your leg kicks, or your whole body jerks, and your eyes snap open. Nothing touched you. Nothing happened. Your heart is pounding, like you just missed a step on a staircase. About 7 out of 10 people feel this at some point in their lives. Doctors call it a hypnic jerk. Most people shrug it off as random. It isn't random at all. The real question isn't why a leg twitches at night. That part has a name already. The real question is why the twitch arrives with a specific feeling attached to it. The feeling of falling. Fair question. Where does a brain that is falling asleep get the idea that the body is falling through space? Physicians noted sudden sleep jerks for centuries before anyone studied them with any rigor. In the 20th century, sleep researchers gave the phenomenon a clinical name, myoclonus, borrowed from Greek words for muscle and sudden movement. Electrode studies later caught the jerk in the act. It fires during the exact transition out of stage 1 sleep, right as brain activity slides from alpha waves into theta waves. The body sits caught between two states, awake and asleep, and something in that narrow gap sets off the reflex. Population surveys put the numbers at roughly 6 to 7 out of every 10 adults experiencing a hypnic jerk at some point, and close to 1 in 10 noticing one on most nights. Stress raises the odds. So does caffeine late in the day, and hard exercise right before bed. None of these triggers involve real danger. The reflex fires anyway. One explanation comes out of evolutionary biology. Sleep researcher Matthew Walker at the University of California, Berkeley, laid it out in his 2017 book, Why We Sleep. Walker points to millions of years our primate ancestors spent sleeping in trees instead of on open ground. A primate relaxing its muscles on a branch risked one specific thing: losing its grip and dropping. Walker's proposal holds that the brainstem still runs that same old monitoring routine. As muscles slacken at sleep onset, the brain reads the drop in tone as an actual fall already underway, and it fires a defensive contraction to catch a branch that stopped existing millions of years ago. The dream that sometimes rides along with the jerk, the sensation of tripping or missing a stair, may be the cortex scrambling to explain a signal that arrived before any story could be attached to it. A newborn baby shows a cleaner version of the same wiring. In 1918, Austrian pediatrician Ernst Morrow described a reflex now named after him. Lay an infant down and let its head drop back even slightly, and both arms fling outward, then sweep back in, as if grabbing for a hold. The Morrow reflex is present from birth and normally fades by 4 to 6 months of age. Pediatricians still test for it during every newborn exam because its absence can point to a problem in the nervous system. Researchers connect the reflex to infant primates that had to cling to a mother's fur while she moved through branches overhead. A baby that felt itself slipping needed an automatic grab. There was no time to learn one. The feeling of falling starts in a small structure behind your ear. Inside the inner ear sit 2 chambers called the utricle and the saccule. Each holds a bed of hair cells topped with tiny crystals of calcium carbonate called otoliths. Gravity pulls on those crystals at every moment. When your head tilts or your body accelerates downward, the crystals shift, bending the hair cells underneath, and that bend turns into an electrical signal racing toward the brainstem. 3 fluid-filled loops nearby, the semicircular canals, track rotation instead of straight-line motion. Together, this network tells your brain which way is down without your eyes ever opening. During the slide into sleep, signals from muscles, eyes, and the inner ear are supposed to power down in sequence. Researchers studying the timing found that the balance signal sometimes lags behind the others by a fraction of a second, long enough to trigger one last false alarm. That alarm travels through one of the fastest circuits in the human body. Neuroscientist Michael Davis, working across Yale and later Emory University, spent decades mapping the acoustic startle reflex, the flinch triggered by a sudden loud noise. Davis traced the path through a cluster of neurons in the brainstem called the caudal pontine reticular nucleus. The signal skips the cortex entirely. In lab animals, the full reflex completes in under 15 milliseconds. In humans, a startle response reaches the muscles in roughly 1/10 of a second, faster than a blink you could consciously choose to make. The falling reflex at sleep onset appears to borrow this same emergency pathway. Compare it to the knee-jerk reflex. A doctor checks with a small rubber hammer. Tap the tendon below the kneecap, and the lower leg kicks forward without any input from the brain at all. A full loop contained in the spinal cord. Blinking at a puff of air near the eye runs on a similarly short circuit. The nervous system keeps a whole set of these shortcuts on standby. Responses fast enough to matter before conscious thought can catch up. The falling reflex belongs to that same family, just triggered by a threat that vanished with the trees. None of this circuitry checks a calendar. It doesn't know that raised sleeping platforms, built from grass and hide, appeared tens of thousands of years ago. It doesn't know that falling out of a modern bed onto a carpeted floor rarely hurts anyone. The brainstem keeps running the defensive program a tree-dwelling ancestor once needed to survive a single bad night, over and over, for every person who has ever closed their eyes to sleep. A newborn flinging both arms out at a dropped head. A hiker's hand snapping out to grab a rail that isn't there. An adult jerking awake at 11 at night with a racing pulse. An acoustic startle finishing itself in the time it takes to blink twice. Different triggers, one emergency line, wired into the body before language, before fire, before the first tool was shaped by a careful hand. 7 out of 10 people will feel that jerk again this week, maybe tonight. Most will forget it by morning or laugh it off as nothing. It carries more history than that. Nobody taught your body this trick. It arrived at birth, older than any memory you own. It is a reflex built for a branch that stopped existing before anyone started counting years. Still running quietly inside a body that now falls asleep on a mattress, behind a locked door, further from the ground than any ancestor ever slept. And still, for one fraction of a second, bracing for the drop.